Hello, I'm Jagan Mohan. Now we will see how to implement this Enigma mission using Java programming language. We also play around using different input text and also trace out the encryption and decryption process. So I have made this entire program into two different files for better understanding and readability. So the first file, mission initial settings, will have only the required variables to work with this mission and also the methods for manipulating only these variables. It does not have any business logic or the important logic required for encryption decryption. And the second file is tester. This is the major file which we have all the business logic and the method for encryption decryption. We also have method for for the rotation of the rotors. Let me bring up the procedure for you for better understanding. So I have made a sticky note. So if you see, for reading the input, of course, we read through scanners, and we need to have plug board. So to swap the characters with A to B or B to C, anything, whatever the desired required. So we have the plug board. For that, I have taken the hash map. Because one character is mapped to other character, I have taken the data types as characters. And we need to have rotors. So in original mission, we have two rotors and one reflector. To customize, we have taken three rotors and two reflectors. So obviously, we need to have two turnover positions when we have three rotors. So every rotor, every reflector will have input pin and output pin. So input pin is represented as just rotor 1, 2, 3 with a letter, and reflector 1, 2. And the output pins are represented using the map. So rotor 1 map, which is nothing but the input is mapping to output of rotor 1 map, and rotor 2 map 3. Similarly, reflector 1 map, reflector 2 map. And if you observe, every character array has the length of 26, because this Enigma mission is designed only to encrypt the letters, not any digits and special characters. So all the alphabets in English can be represented using 26 length of array size. So that's why I have taken 26. And this also has one default constructor where I will set my initial configurations for the mission, the rotor and reflector, the values, the all 26 values, at which position what character is existed. And I have one parameterized constructor also if I don't want to work with these initial or default settings. If I want to work with the different settings, so I can just use this parameterized constructor and set my default settings. And also for every variable, I have one getter and setter. So getter is basically used to fetch the value, because I'm doing all my business logic in another file. So I definitely want to fetch value from this file. So I have getters. And also I have setters. If I want to modify the existed value, we know that whenever we are performing encryption or decryption, the rotor positions will be changed because of the rotations. So I need to modify the value. So for that purpose, I'm having setters here for every variable. So this is all about this initial file. And next we have tester. This is the major file which has the business logic for encryption and decryption, and also the logic for rotation of rotor position, and also the main function where our execution of program starts. So if you see, as I mentioned, this mission will only encrypt the letters. I need to handle if user enters the numbers or special characters. So I'm handling it using the try catch block. So whenever I enter non-characters, it will just show me invalid. I'm not performing any over engineering here, because I don't want to show up the user explicitly what he was made the mistake. Because indirectly, if we mention what is the mistake, okay, you are not supposed to enter character, you are not supposed to enter the letters. We are giving the hints to the user that, okay, I want to exclude this. So I'm not doing that, I just printing the invalid message. So once the main method execution starts, you can say I'm calling the default constructor method here, so that all my initial values for rotors and reflectors will be set. After that, I'm taking three variables for reading the message from user, the plain text, and to store the encrypted message, and to store the decrypted message. So up next, after reading the message from user, I'm passing character by character to this encryption method so that it will encrypt and give me back the encrypted text. So taking character to this method, it will first check whether that particular character has any mapping in the plugboard. If it is yes, it will fetch that. If it does not have any mapping, it will directly fetch the given value. And next it will pass to routers in the forward direction, like router 1, router 2, router 3. You can see here, first it will go to the router 1 input pin and router 1 output pin. Similarly, router 2 input, router 2 output, router 3 input and router 3 output. So once it passed through the rotors, it goes through the reflectors, and the reflectors, we have two reflectors, reflector 1 input, reflector 1 output, reflector 2 input and reflector 2 output. Again, now we have to travel back to the plug boards from reflector 2 to the rotors to the plug board. So for that, I have again function here. The input pins becomes output and output pin becomes inputs. So first I'm going to the output pin, then I'm mapping it to the input pin. Similarly, router 3 output pin and router 3 input pin, router 2 output and router 2 input, router 1 output and router 1 input. So once after passing through the routers, again, I need to check if there is any mapping in the plug board. So I'm checking that mapping here. If there is any mapping, I'll get that mapped character. If not, I'll get my character back. So now encryption is done. We know that once encryption is done, we need to rotate the rotor position of router 1 for 2 steps, as we have customized it to 2 rotations. So we are rotating our router 1 to the 2 positions using this change rotor position function. And if my router 1 after rotation is completed, if it is at the turnover position, so I definitely need to rotate my rotator 2 also. So I'm checking the condition here. If it is true, I'm rotating my rotor 2 for 2 positions. And after rotation of rotor 2, again, if it reaches a turnover position, so again, I need to check the condition and rotate my rotor 3 for 2 positions. So this function basically handles the rotation of rotor's position. So this is the process of encryption. So it will pass character by character and just store that encrypted message in the variable called encrypted message. Once the encryption is done, in order to decrypt, I need to set my Enigma mission to the initial settings. So I'm calling this default constructor again to reset my Enigma mission settings. So after that, I will pass my encrypted text character by character to the same method, because the process is same. We go through the plug boards and then to the routers, reflectors, back to the routers from reflectors and plug board. So I'm using the same function. I don't want to make any duplication, making 2 separate methods. So once we pass the encrypted message character by character to this, we get the decrypted message. And remember that we must rotate the rotors even after every character decryption, not only during encryption, even during the decryption too. So this is the decryption. Let's execute and see some examples now. So first, let's check the invalid characters. I'm giving some special cases. You can see it could not encrypt and it shows just invalid. Next, let me give some letters. You can see again this is invalid. Now go with some the valid text, the strings, simple text hi. You can see the hi is exited to B and F, and again back. I'm resetting my Enigma mission to initial settings after the encryption, and I'm performing decryption. So I got my text back hi. So this is my initial text which I entered, the plain text, and I initialize my Enigma, performing the encryption for character H, performing the encryption for character I, and then I have got my encrypted message. Now I will pass this BF as input to the method, and I'll get my plain text. You can say I reset my settings. So the encrypted text first letter B is passed and I got H, and my encrypted text F is passed and I got hi. So this is how encryption and decryption works. Let's trace out how exactly this is happening. So I have just copied from the output console to show you the flow of encryption and decryption. So let's do it for hello. So for hello, if you see there are two consecutive L's, even though there are two consecutive L's, if you see our mission is not encrypting them to the same characters. If you see the first L is encrypted to U and the second L is encrypted to M. So this is where Enigma mission stands out of other, cipher missions. So once decrypting this BUMO, I'm getting my plain text back hello. So let's see when I pass H, this is my initial Enigma mission settings. When I pass H, H is mapped to G in our initial mission. You can see here H is mapped to G. And this is the output pin of plug board. And that output is mapped to index of rotor 1. And the G is found in the output pin of rotor 1, matched with the index in rotor 2. And matched with character, matched with index, matched with character, matched with index, matched with character. So basically, whenever we are mapping with input pin, we are mapping it to the index. Whenever we are mapping to the output pin, we are mapping to the character. So here, this is the pin. So we are mapping to the index, G to the G. And coming to the output pin, we are mapping to the character, G to the G. And here again, G, it is an index 25. So index 25, we have Z. And Z is mapped to the character Z in output pin. So this is how the flow works. So the white line represents the forward flow and the yellow line represents the backward flow. So once I encrypted my H to B, you can see that my rotor 1 initial positions are A, E, B, D at index 0 and 1. So after encryption, I need to perform the rotation. So if you see after rotation, my rotor 1 position changed to C, C, D, V, which are actually at position 2 and 3. So which actually means that what are all there at 0 and first injection will be moved to the bottom of the index 24 and 25. So this shows the rotation of our rotor. Similarly, while decryption, I have seen that H is encrypted to B. So I must reset my Enigma mission to the initial settings. And when I pass B through plug board, it goes to A. A is mapped to the same index A, mapped to the character, mapped to index, character, index, character, index, character. So this is the forward flow and this is the backward flow again. Now after decryption also, we are performing the same rotation. So rotate it to the two steps. So initially it was AE and BD. You can see that AE, BD are at the bottom of the rotor. So it is rotated to two rotations. So this is how encryption and decryption works in Enigma mission.